So this is problem number 4 off the worksheet. So the problem involves two lovers 10 meters away from a cliff, and a jealous suitor attaches a 50-kilogram mass to the end of the car and hangs it off the edge of the cliff. And we were supposed to first draw the force diagram for the rock in the car. So for the rock, we just put the weight, which is the force acting on the mass, and then the tension of the rope up, and then our net force vector down, because that makes sense because the acceleration is downward. And then force diagram here is tension up, weight down, tension being less. The car has a force diagram of tension this way, net force up, and weight down. And when we put those vectors into a vector sum diagram, we get weight, tension, normal, and the net force vector going that way, and that makes sense because the acceleration is towards the right. And so, the weight of the car is 10,000 newtons, because we were given that the mass of both the people and the car are 1,000 kilograms. So the weight equals 10,000 newtons. I know you can't see it because it's blocking, but there's a 1 there. The tension is 500 newtons because the rock weighs 50 kilograms, and due to the conversion factor, 1 kilogram equals 10 newtons. We get 500 newtons here. And as you can see from our force diagram, the sum of the forces is equal to the tension because they're parallel and they're equal in length. So, and tension equals 500 newtons. So the formula for net force is mass times acceleration. Since the net force is equal to tension, and tension equals 500 newtons, that means the sum of the forces would equal 500 newtons. We take the mass of the car, which is 1,000 kilograms, and then the acceleration, which we're trying to find. We divide by 1,000, and we get the acceleration equals 1/2 meters per second squared. And then for C, we're supposed to find how long, I believe, it takes when the people will fly off the edge. So we use the final position equation, xf equals 1/2 at squared plus v naught t plus initial position. Xf equals 1/2 times the acceleration, which is 1/2 meters per second squared, times t squared plus 0 meters per second, which is the initial velocity, times t plus 0 meters. So we get 1/4 meters per second squared t squared. So we divide by 1/4, which means that we have to multiply by the reciprocal, which is 4. So 40 meters, you're right, yeah, 40 seconds squared equals t squared, square root of t, and our final answer is t equals 6.32 seconds.